Hello and welcome to Stories of Science. Here, we look back on humanity's long journey to understand the world. The questions, the failures, and the breakthroughs that slowly changed how we see the universe and ourselves. We tell science as stories. Unlocking the Universe, Brian Greene's story. Imagine a little boy sitting on the carpet in a New York living room. He's not playing with toys. He's doing mental math with 30-digit numbers. Yes, you heard that right, 30 digits. At the age of 8. While other kids are still struggling with their times tables, this boy was already pondering big questions. What would he go on to do? He didn't open a coffee shop, nor did he invent a new game. He asked the biggest question of all: what is the universe? How many dimensions does it really have? One day, he realized the universe might not just be three-dimensional. It might not even be four-dimensional. It could have 10 dimensions. That's 7 more directions than your room has. That's 7 more spatial dimensions than the place where you lose your socks. Today, we're talking about this very person, Brian Greene, the physicist who knows how to tell the best stories about string theory. He uses math and poetry to explain the universe, comparing it to a trampoline. He says, imagine you're standing on a mattress, your weight causes it to sag. That's gravity. Now, imagine there are countless tiny strings vibrating on the mattress. Those vibrations are the fundamental particles that make up the world. Sounds crazy, but that's the mystery he's been chasing his whole life. In this next part, you'll hear about his childhood adventures, how he used math to play with the universe, and how he made even the most complex physics more entertaining than your family's funniest jokes. Ready? Let's dive in. He was born on February 9, 1963, in the bustling New York City, a place that never stops moving, like a stage that's always on. Half the people here are chasing time, and the other half are chasing dreams. But young Brian? He was chasing numbers. His dad, Alan Greene, wasn't a famous physicist. He was a singer, a performer, and a bit of an old-school visual artist. He'd sing and write music at home after dinner. Melodies often filled the room, but young Brian wasn't too interested in music. He was more curious about why the numbers on the bill didn't line up. His mom worked as an office manager at a veterinary clinic. She handled all sorts of animal bills, appointments, and shots. The clinic was always busy. Maybe that's when Brian started thinking, what if I could categorize these animals by their traits? Wouldn't that be fun? Brian didn't play with remote-controlled cars. He didn't watch cartoons all day. His toys were the long strings of numbers his dad wrote on paper. Dad would say, "Hey, let's see who can solve this faster." And little Brian would often win. By a landslide, while other kids were still counting 1, 2, 3. He was already figuring out how many different ways numbers could be arranged. Most kids only see this many combinations when it comes to candy, family gatherings. They were another stage for math. Relatives would sit around, some would play cards, others would chat about the weather, but Brian's parents would quiz him. What's 6 times 8, plus the temperature outside? What's the square root of your cousin's shoe size? In these normal family interactions, Brian would smile and give his answers, earning the most applause and confused looks. He grew up on the Upper West Side of Manhattan, where, as he walked down the street, he didn't see the neon lights. He saw the angles, distances, and possibilities between the people around him. While others saw taxis, he might have been wondering, what if taxis ran on a probability distribution route? Would they be faster? In his mind, he also saw the towering American Museum of Natural History, with its massive dinosaur skeletons, but what really caught his attention was the astronomical clock. The giant disk spun continuously, as if reminding him time and space. There's more to it than meets the eye. While others were still learning their multiplication tables, Brian was already thinking about who invented geometric shapes. Why are circles more elegant than squares? It might sound like a philosophical question, but for him, it was more like a math game. He was always blunt when speaking. When someone asked what he was having for lunch, he'd respond, "Why are there only 3 choices for lunch?" People would be puzzled. He'd add, "I'm wondering if there's a 4th, better option." He eventually made it into the legendary Stuyvesant High School, one of the hardest public schools to get into in New York. It was a haven for math and science enthusiasts. There, he discovered, oh, there are others who love numbers as much as I do. He and his classmates didn't race to see who could run faster, they competed to see who could make complex equations look more elegant. They debated, what would the universe look like if it had extra dimensions? While others were deciding whether to order takeout, he was already thinking about how many dimensions space had. This isn't an exaggeration. It's the true trajectory of his growth. While others were playing games to improve their hand-eye coordination, he was using numbers to build his logic muscles. Little Brian wasn't forced to love math. He found numbers amusing. To him, they weren't dry formulas, they were stories, riddles, jokes, and he was the kid destined to solve those puzzles. That was his early life. A boy for whom numbers were more fun than toys, the one who won the most applause at family gatherings, the one who was already making friends with the rules of the world from a young age. When he was in elementary school, while others were still learning 2 times 3, he was already wondering why 2 times 3 isn't the same as 3 times 2. Stuyvesant High School was one of the toughest public schools to get into in New York. The exams were like solving an unsolvable puzzle. In the years before 1980, Brian Greene earned his way into this elite breeding ground with excellent grades. There, for the first time, his classmates realized there's someone who treats math like a way of life. He participated in math competitions, not the small, local ones, but citywide, national-level contests. Other kids wrote down answers. He was already mentally arranging his strategies. Before the question was even finished, the answer was already in his head. Math teachers would often have this look on their faces: I write slower than him, but he solves it faster. Once, a teacher even said, I can't read your notes because my brain can't keep up. Stuyvesant's math club wasn't about playing cards. It was the arena for high-dimensional geometry and equations. While others played hide-and-seek, he played with calculus. When someone asked why he loved math so much, he shrugged and said, it doesn't lie to me. Sounds a bit philosophical, right? But when you mentally solve a complex equation in a second, you know just how sweet that confidence feels. In 1980, he was accepted to Harvard University. He was about 17 years old. Harvard was one of the top universities in the country, even the world. He majored in physics, not because he liked jokes, but because he wanted to figure out the true rules of the universe. At Harvard, he was unbeatable in his studies. He graduated summa cum laude. In other words, while others aimed for an A, he got the kind of grade that made an A look tired. Harvard's library was a treasure trove of knowledge for most students. It was a quiet place to study. For Brian, it was a battlefield. He often stayed up late writing reports. At night, the library was deserted except for him and the bookshelves. Occasionally, security would come by to patrol. They'd see a person hunched over a desk and think they'd spotted a ghost, but it was just a mad physicist, and he wasn't a lonely study machine. He had friends. They'd discuss problems together. One time, a classmate asked him what's the hardest problem in the world. He thought for a second and replied, the hardest problem after the universe is explaining why the universe loves rules. Harvard wasn't all about books and equations. There were bingo games, soccer matches, and coffee chats, but Brian wasn't easily pulled away. He had too many formulas running through his head, but he would laugh, too, when someone said, let's go grab coffee. He'd ask, when are we discussing 4-dimensional spacetime? His classmates would widen their eyes and say, are you going for coffee or preparing for an exam? He'd laugh and reply, both. At Harvard, he wasn't just there to rack up high grades. He was learning how to converse with the universe. Every problem he solved wasn't about proving how smart he was, but about asking the question, how does this world really work? Others might have seen math as a subject. For him, math was the key to the real world, and that key had just unlocked its first door. He earned the Rhodes Scholarship, one of the oldest and most prestigious scholarships in the world, often called the Nobel Prize for undergraduates. He didn't go for a vacation. He went to Oxford University and began his most fascinating journey. It was 1984. With a big backpack, he flew across the Atlantic. The weather was gloomy, the rain in England seemed to always be on replay. And as soon as he arrived, he dove into the deepest questions. At Magdalen College, Oxford, he focused on string theory and cosmology. His dissertation title sounded like a riddle: superstrings, the impact of topology, geometry, phenomenology, and supersymmetric models on astrophysics. In simpler terms, he wanted to connect the smallest particles with the entire universe. He wasn't just writing formulas. He was trying to uncover the deepest structures of the cosmos. During those years, he didn't just bury himself in papers. He also learned piano. At Oxford, his mentor encouraged him to step out of his study and engage with another way of thinking. So you might imagine this American physicist in the mysterious town of Oxford. On a rainy day playing the piano, but in his mind, Pondering the dimensions of the universe, someone joked the rain there is more frequent than the formulas he was studying. He even joked, when I was writing my thesis, the sound of the rain was like the strings playing their own symphony. Though no one can confirm he actually said this, his friends certainly joked the rainy days were more than enough to match the formulas he was studying. Years later, he completed his PhD. In 1987, he officially earned his DPhil from Oxford University. He was over 20 years old, and his obsession with the universe was just beginning. He didn't return to New York immediately. Instead, he went to Cornell University, located in the peaceful town of Ithaca. It was a place perfect for thinking. In 1990, he officially became a professor in the Department of Physics there. He was just 27. At first, his students might not have known who he was, but they quickly realized the seemingly quiet professor had the universe's source code in his mind. In class, he didn't just recite formulas on the board. He asked his students, do you think space is just three-dimensional, or is there more? The students were confused. One bold student said, Professor, could there be many ways to cut a pizza, like in different directions? Brian smiled and replied, exactly. Imagine a pizza with 10 directions, that's like the universe in string theory. His students gave him a nickname, they called him the Cosmic Navigator. Not because he would take you on a trip, but because he could navigate through the dimensions of space. He wasn't the kind of professor who only cared about research. At Cornell, he balanced both teaching and research. His classes were witty and engaging. He made complex equations sound like cosmic jokes. His students said that attending his class was exhausting, and not because it was boring, but because it was so much fun. He patiently answered all sorts of questions at once. A student raised their hand and asked, Professor, how many dimensions does the universe have? He thought for a moment, smiled, and said, if you get lost in 10-dimensional space, you might need a GPS. The class erupted in laughter. His performance at Cornell was stellar. People started saying his future was limitless. In less than 5 years, his name was becoming well known in the string theory community. Then, in 1996, he made a major decision. He moved back to his beloved New York. He became a professor at Columbia University, not only in the Department of Physics, but also in the Department of Mathematics. This wasn't common at universities, because it meant you didn't just specialize in one field, but cross two different ways of thinking. At Columbia, he continued to teach, to research, and to use humor to explain the deepest parts of physics. He would say, if you think math is abstract, it's because it hasn't yet embraced your life. Some students even said his classes were as exciting as watching a sci-fi movie and taking notes. He showed his students that physics isn't just theory. It's about the floor beneath your feet. It's about the chair you sit in. It's about the dimensions you might never see. He always laughed and said the universe isn't arranged like a dictionary in a neat order. It's more like a fun puzzle box. You never know what the next layer will hide. From Oxford's rainy nights to Cornell's lecture halls to Columbia's grand auditorium, he's always been leading his students, with humor and determination, to unravel the secrets of the universe, and these secrets are just the beginning of his scientific story. In 1999, Brian Greene dropped a book that got the whole world's attention. It was called The Elegant Universe. Now, the title might make you think it's a travel guide or something, but no, it was all about string theory and hidden dimensions. Basically, the universe might be way weirder than you think, like, a lot weirder. This book didn't just hit the bestseller list, it was nominated for a Pulitzer Prize, and it won the Royal Society Science Book Prize in the UK. People suddenly realized, who knew? Theoretical physics could be written like a page-turner. Then, in 2003, PBS turned it into a 3-part documentary for their Nova series, and get this, Brian Greene was the one in front of the camera, explaining it all, but not with a bunch of formulas. No, he made it like a story about the universe. He even used a piano to explain the vibrations of strings, not the classical concert piano you might be thinking, but more like, imagine there are countless tiny strings vibrating in space. You pluck a string, you hear a sound, and in Brian's mind, that's the note that makes up everything in the universe. So he told his students, picture the universe as a piano that's always playing. After The Elegant Universe, Brian became the kind of guy you could spot in a coffee shop. A true physics celebrity. Journalists would ask him, to understand the universe, you first have to understand the glasses you're wearing to see it. Sounds deep, right? But then, he actually showed you, using charts, how to turn those glasses into a 3D model. 5 years later, In 2004, he dropped his second book, The Fabric of the Cosmos. It delved deeper into the nature of space, time, and reality itself. Some called it the owner's manual to the universe, and guess what? PBS turned it into another visual masterpiece. There were spinning galaxies, time bending, space weaving, way more exciting than most sci-fi movies. By 2010, Brian took on something a bit different. He worked on a stage play called Icarus at the Edge of Time. It was a multimedia experience, inspired by the ancient Greek myth, but set at the edge of a black hole. It had music, visuals, and scientific explanations. Think of it as bringing science into the world of theater. Then in 2011, he published The Hidden Reality. This book explored the possibilities of parallel universes and multiple dimensions. It wasn't a sci-fi novel. It was serious physics, written in a way that felt like a thrilling adventure. Then in 2020, he released Until the End of Time. This one wasn't as focused on equations as his earlier works. Instead, it was more like a long philosophical and scientific journey, telling the story of the universe from the Big Bang to its potential end. It was a deep dive into time, space, consciousness, and human civilization. After these books hit the shelves, Brian Greene became a regular on TV, from PBS documentaries to late-night talk shows, even news interviews. When he talked about physics, it was like hearing your funniest friend tell you a joke you can't help but laugh at. People just couldn't help but say, "Oh, that's how it works." At home, even his cat probably heard a thing or two about the universe. There's a joke that he and his cat would discuss multidimensional space. Of course, the cat was only interested in canned food, but Brian swore the cat seemed to understand the hidden dimensions. At least, it always jumped to places he least expected. Brian Greene didn't just make science popular. He truly influenced a whole generation of young people. Some fell in love with physics after reading his books, others finally got what space wasn't just up, down, left, right. Some even said, after reading his books, my imagination went from 3 dimensions to infinite dimensions. Imagine that. We're not just living in a box of 3 dimensions, there might be more hidden directions, like secret pockets in your backpack that you didn't even know were there. And Brian Greene is the one telling you, hey, your world is bigger than you think. With humor, metaphors, stories, and science, he took the deepest secrets of the universe and turned them into something anyone could understand. That's how he brought science to the masses. Now, Brian didn't just get into string theory to impress people. He had a simple, age-old question to answer. What is the universe made of? The answer wasn't points. It was strings. In traditional physics, particles like electrons and photons are thought of as little dots, but in string theory, they're not dots. They're one-dimensional strings vibrating, and depending on how they vibrate, you get different particles. It's like the way a guitar string can play different notes. High or low sounds poetic, right? But it's mathematically precise, and there's one small catch: the universe needs more than the 3 familiar dimensions we know. A string theory works best if there are 10 dimensions. Sounds like sci-fi, doesn't it? But this is cutting-edge theoretical physics. So why do we only see 3 dimensions? The answer is that these extra dimensions are tightly curled up. Imagine a super long wire. From far away, it looks like just a line, but when you get close, you realize it has thickness. It's circular. This is a basic analogy for hidden dimensions. These hidden dimensions have a specific shape called Calabi-Yau manifolds. They aren't your regular geometric shapes. They're 6-dimensional, fantastical spaces. If you think of these spaces as cosmic Play-Doh, then how you mold it will change how the strings vibrate. These vibrations decide things like the mass of particles and the strength of forces. Essentially, they govern everything in the universe. In the mid-90s, Brian and his collaborators began studying how these manifolds change. They explored what's called the Calabi-Yau moduli space, the universe warehouse that contains all possible 6-dimensional shapes. In this space, 2 shapes that look totally different can produce the same physical effects. This is called mirror symmetry. The term mirror might sound like magic, but behind it is a deep mathematical symmetry. Picture yourself in front of a bathroom mirror. Your reflection looks like a flip of you, but if you try to reach out and touch the mirror, you can't actually touch your mirror hand. In string theory, Two seemingly different spaces can have this mirror equivalence, they look different, but the physical rules they produce are the same. What started as a beautiful idea in mathematics, Brian and his team turned into a powerful tool in theoretical physics. They proved that two different Calabi-Yau spaces, like two different book covers, actually contain the same contents. This blew the minds of both mathematicians and physicists. In this work, they published a paper in 1993 showing how smooth mirror connections work between different shapes. In a way, this means the hidden dimensions of the universe can change like a wardrobe swap, but the basic physics stay the same. Around this time, another major discovery was made: topology changed. In the framework of string theory, the shape of the universe can split and reconnect. This is wilder than anything we learned in high school geometry. It's like turning a donut into two lollipops, the middle can tear and reconnect. Something called a flop transition or conifold transition in math. Conifold comes from cone-shaped points, a singularity of Calabi-Yau space. Brian showed that in certain situations, the universe's space could safely pass through these singularities, like a cosmic renovation. These contributions tied Calabi-Yau spaces, mirror symmetry, and topology change together. Not only did it make physicists go wild, but it also rekindled mathematicians' passion for geometry. Imagine you've got some strange origami, you slowly fold its corners back, and at some point, it might look like it's tearing, but with one more fold, it turns into a totally different shape. This is what Brian was describing in his theory. It might look wild, but in math and physics, it's as rigorous as it gets. And when we talk about rigor, this research didn't happen overnight. It was built up over decades. Back in the early 90s, he was already diving into these directions. A landmark paper in 1994 was the result of a collaborative effort. In that paper, they analyzed the Calabi-Yau moduli space, showing how topology change could happen smoothly in physics. Brian and his collaborators also studied how string theory could connect with cosmology, like looking for quantum gravity's imprint in the cosmic microwave background from the Big Bang. For these contributions, Brian received the NSF Young Investigator Award in 1992 and the Sloan Fellowship in 1993, marking his growing influence in theoretical physics. After that, he didn't just stay in the academic world. His ability to explain complex theories clearly earned him honors like the APS Science Communication Award. In the classroom, he often used everyday metaphors to explain tough concepts. For example, he'd say, imagine you have a sock. If you hide a dimension inside the sock, how would you ever find the end of it? This humor made high-dimensional concepts fun and easy to understand. Or, when explaining mirror symmetry, he described the two spaces like cosmic twin brothers. They look different but live in perfect harmony. He'd joke, if the universe really has 10 dimensions, one of them might just be where I keep losing my socks. These simple metaphors helped people understand concepts like why higher dimensions affect the particles we see in our world. Some even said he was the cosmic bridge builder, connecting math with physics, abstract theory with intuitive imagination. But the real value wasn't just in the humor. It was that he helped so many people understand this profound idea: the universe might not be as simple as we see with our eyes. It's a world filled with hidden dimensions, mirror symmetry, and the potential for spatial transformations. This work made him one of the key figures in string theory. Brian Greene's impact on science goes far beyond writing dense academic papers. He tackled one of the most fundamental questions in theoretical physics: how do we unify the laws of physics into a single, cohesive theory? This was a lifelong pursuit for Einstein, and it's a dream that Brian Greene inherited. In modern physics, there are two grand theories. One explains the large-scale structure of the universe, general relativity. The other explains the behavior of the tiny, subatomic world, quantum mechanics. But here's the kicker: these two theories don't get along. At the center of black holes or in the first moments of the universe's birth, they behave like two dancers doing completely different routines. Unifying them is one of the biggest challenges in physics, and string theory is one of the most exciting contenders in this race. It's trying to bring all four fundamental forces, strong, weak, electromagnetic, and gravity, into one unified framework, and Brian Greene is a key player in this unification race, working to turn a concept once only understood by physicists into something the general public could grasp. His 1999 book The Elegant Universe introduced the world to the idea that strings aren't points, but vibrating lines. This wasn't just a bestseller, it made people who had never cared about physics think, what? We could have 10 dimensions. Of course, not everyone in the scientific community was immediately convinced, as some critics pointed out that string theory still lacks direct experimental evidence, but even so, it remains the most promising mathematical framework to potentially unify quantum gravity. Thanks to Brian's clear explanations, many people for the first time understood the theory of everything isn't just a fantasy. It's really something that could happen. At least in terms of our thinking, it's possible, and that's a major shift in how we approach the universe. This influence wasn't confined to academia. He wrote books, and people read them. He appeared on TV, and audiences sitting on their couches could grasp complex ideas that once seemed out of reach. This is science communication at its finest, and it's raised the public's scientific literacy. Countless young people, inspired by his work, started asking, why is the universe the way it is? If there are multiple universes, how can we prove it? If time has more dimensions, could there be another me out there? These are questions more challenging than anything you'd find on a high school physics test, but thanks to Brian's books and voice, these once lofty ideas became common conversation topics. At public lectures, festivals, and science talks around the world, when people heard Brian Greene, it felt like hearing Carl Sagan or Stephen Hawking. Not because he could scare people with fancy formulas, but because he could break down the universe's most complicated ideas like you were chatting with a friend over coffee. He even co-founded the World Science Festival, a celebration designed to make science something everyone can engage with, experience, and share. He turned science from a secret locked away in labs into something as accessible as a music festival. Once, someone wrote to him asking, "Professor, can you help the universe with its homework?" It sounds like a joke, but it reflects the desire so many people have for science. They want to participate, they want to understand, and they want to think critically. In fact, science communication isn't just talking about facts, it's about inspiring action. It's made more young people take their first steps into STEM fields. For many, it wasn't about winning scholarships. It was about feeling the wonder and beauty of the universe for the first time. Right through Brian's words, he used humor to explain time and space. He once said, "If the universe has extra dimensions, maybe one of them is where I keep losing my socks." These exaggerated yet everyday metaphors showed the human side of the science behind the theories, but Brian's influence didn't just stop at the sciences. It spilled over into philosophy. Does a multidimensional universe mean that you and I are just projections of some other world? This kind of discussion is no longer reserved for physicists alone. It's entered philosophy classrooms, pop culture debates, and even science fiction. It's even made people question the very nature of reality itself. When people talk about parallel universes now, it's not just Marvel movie stuff. It's a serious, physics-backed conversation, and that influence might even extend to future technologies. While string theory hasn't been directly verified through experiments yet, it's pushing forward deeper thinking in areas like quantum computing and AI simulations of complex systems. These fields all depend on understanding and simulating incredibly complex systems. Imagine if one day we could simulate a system that operates under 10-dimensional rules. It would revolutionize everything from computing to materials science to our very understanding of life itself. This isn't science fiction, it's the first step science has taken toward a new technological era. Brian's contributions earned him a reputation as a master of explaining string theory, not because he could memorize formulas, but because he could tell the story behind the formulas. Once, an audience member called him the real-life Sheldon Cooper. Not because he was funny, but because, when talking about the universe, he brought a childlike curiosity and determination. He's often described as humble and approachable. In the classroom, he'd smile and explain complex questions. In a crowd, he'd patiently answer every question about the universe. This down-to-earth attitude made physics feel less like an inaccessible mountain and more like a puzzle anyone could solve. For many people, Brian Greene isn't just a physicist. He's someone who made us all feel like we could ask the universe questions. He's not just a scholar writing formulas on a chalkboard. He's the person who got the world to start asking serious questions about the universe. The theory of everything, once a topic reserved for scientists, has become something the public can understand. All thanks to him, the unification theory seeks to pull together all the seemingly different rules of physics. General relativity explains the large-scale structure of the universe, while quantum mechanics explains the chaotic, tiny-scale world. In the past, These theories were like two old neighbors who wouldn't even talk to each other. Brian Greene and his colleagues are trying to get them to shake hands. The string theory is one of the bridges between them. It explains all the fundamental forces and particles as different vibrations of strings. Sounds poetic, doesn't it? But it's an extremely serious mathematical attempt to. His books made this once esoteric idea into something people could actually understand. The Elegant Universe, published in 1999, was the key that unlocked the door to these ideas for millions of readers. It wasn't just an academic text. It became a bestseller, translated into multiple languages, and introduced the concepts of hidden dimensions and strings aren't points, they're lines of millions around the world. His 2004 book, The Fabric of the Cosmos, delved deeper into the nature of spacetime itself. Using everyday analogies, he made readers understand ideas like, why does time have a direction, and is space a tangible thing? In 2011, he followed it up with The Hidden Reality, introducing the concept of the multiverse to a wider audience. Parallel universes were no longer just science fiction, they were serious physics. His latest book, Until the End of Time, took us on a journey through the entire lifespan of the universe, exploring the relationship between consciousness, life, and the meaning of existence. These books made people realize quantum mechanics isn't just about dry formulas. A string theory isn't just mystical nonsense. The universe isn't just a mysterious black box. It's a mental adventure we can all understand. Because of these books, many students for the first time thought physics might actually be fun. They stopped just grinding through textbooks in class, they started buying books, discussing ideas, and signing up for university physics courses. Some even wrote to him, "Professor, can you help us with the universe's homework?" Brian humorously replied, "If the universe really had homework, I'd probably need to review too." His impact goes far beyond just his readers. Around the world, his name has become synonymous with high-quality science communication. His work has helped turn science from something hidden in labs into something everyone can participate in, something people can experience and share. Public scientific literacy isn't just a slogan anymore. People are choosing to major in physics, math, and cosmology because of the questions Brian sparked in them. He's made these topics, from extra dimensions to parallel universes, accessible to everyone. He's not just making complicated ideas understandable. He's showing us that asking questions about the universe is something anyone can do, whether or not you have a PhD, and his ideas have even started seeping into philosophy and culture. If the universe has multiple dimensions, what if there are infinite parallel worlds? These questions no longer belong solely to scientists. They're entering the realms of philosophy, literature, film, and even cartoons, shaping the way we think about the nature of reality. Some people even say, when we look up at the night sky, we might just be a shadow in a three-dimensional world, with more dimensions waiting to be discovered in the higher dimensional space. That's the open-endedness of science, not to confuse you, but to spark your curiosity. Brian Greene's work has also been described as humble and approachable. Despite his global fame, he's always willing to answer questions from students. He explains the deepest questions with the simplest examples, making complex ideas feel accessible to everyone. In this age of social media, he's been compared to a real-life Sheldon Cooper. Not because he's funny, but because he brings a childlike curiosity and determination to his cosmic explorations. Imagine those ancient physics puzzles, they used to be massive mysteries locked deep in time. Brian Greene didn't just write the key to open those mysteries. He handed us each a copy. Even if you're just someone curious about the universe, some might say, the strings really are singing. Let's just hope they like our playlist, because, after all, those vibrating things might have more rhythm than our everyday music. And when you look up at the stars at night, when you imagine that the universe could have hidden dimensions, remember you might just be a tiny speck in a 10-dimensional universe, and that sense of wonder and curiosity is the most valuable part of our journey to understand the cosmos. The people who change the world usually just think one step deeper. If this story made you see things differently, hit like, subscribe, and save it. See you in the next story.